Hi, and welcome to our first lesson of Unit 1. We're going to do an introduction to proofs, and we're going to start with something that we understand, which is our algebra skills. In geometry, oftentimes we're going to be asked to prove that something is true. Okay, so we're going to be using algebra problems to learn how to do this proving process. Okay, so when proving an answer is true, you have to justify each thing that you do to get from one step to the next in solving your problem. So let's explore some examples using the algebra skills you already have. So let's say I have the problem x minus 2 equals 6, and I want to say prove to me that x equals 8. Well, I know that what I would have to do, let me zoom in so we can see this a little bit better. I know that what I would have to do in order to solve this problem is I would have to add 2 on both sides. I'd have to do a plus 2 here and a plus 2 here to move that to the other side of the equals, making this become 0, so x plus 0, which is just x, equals, and then the 6 plus 2 is 8. So when we add on both sides, when I'm in the proof and I have to write off to the side what the justification is, that is called the addition property of equality. And you'll see me abbreviate that a lot of times when we do the proofs because that's a lot to write. The property of equality, a lot of times I'll just write O-E for property of equality. So just kind of shorten it up for us. Okay? When I look at the next one, I see x plus 2 equals 6, and I want to prove that x equals 4. So in this problem, when I'm doing x plus 2 equals 6, how did I get from that to x equals 4? I know that this 2 moved to the other side by subtracting on both sides. So guess what we call that? We call that the subtraction property of equality. Or again, P-O-E for property of equality. All right, when I look at the next one, number 3, I have x over 2 equals 6. So I know when I see that fraction, x over 2, that means I'm dividing. So it's x divided by 2 equals 6. So to get from there to x equals 12, I know that what I really did is I multiplied both sides by 2, so that on this side my 2's would cancel out, and on this side I've got 6 times 2, which is 12. So that is we multiplied by 2 on both sides, so that is the multiplication property of equality. All right, we've done addition, we've done subtraction, we've done multiplication, so guess what's next? You probably guessed correctly. I have 2x equals 6 turns into x equals 3. How did I get rid of the 2 on the x? Well, it's 2 times x, or 2 multiplied to x, so I needed to divide on both sides by 2. So this is the division property of equality. So we have addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. In both of those cases, you're taking the addition, subtraction, multiplication, and division, and you're doing it to both sides of the equal symbol. What you do on one side, you have to do it on the other side, and that's what keeps our equations balanced and equal. That's our property of equality. Okay? All right, couple more. We have 3 more we're going to look at today. I have a plus b equals 8, b equals 3, and then it wants to know, knowing those 2 things, then how would I know that a plus 3 equals 8? So if I look at this, I have a plus b equals 8 on the first line, and then my third line is a plus 3 equals 8. So what I did is I took that b and I replaced it, so now it's a 3. And the reason I can replace it is because b is equal to 3. So b can be replaced with 3. Do you remember what that's called? That is the substitution. Property of equality. Okay. Substitution. So if you're ever abbreviating, be real careful when you're abbreviating, and don't abbreviate too much, because if I can't tell the difference between substitution and subtraction, you've abbreviated too far. Okay? All right, so when I look at the next one, I have 3 parentheses x plus 2 parentheses equals 8. So 3 times x plus 2 equals 8. How do I get from there to 3x plus 6 equals 8? Okay, so what I need to do, or what I did to get from here to here, is I multiplied 3 times x, and then I multiplied 3 times 6 to get, or 3 times 2 to get 6. So it's real tempting to say, oh, well, we multiplied the 3 to both, so it's multiplication property of equality. But remember, multiplication, addition, subtraction, and division have to happen on both sides of the equals. This is just happening on one side. Nothing's happening. 8 is still 8. Nothing happened on the right-hand side. Okay? So this we distributed into those parentheses. This is the distribution, or distributive. You can write it either way. Property of equality. Okay. And then last one we're going to look at today, I have 3 plus x plus 2 equals 6. Okay, so I can see what we did here is, notice on the right hand side I still equal 6. Nothing changed on the right hand side. It was only on the left hand side. My x is still x, but my 3 and my 2 got added together to become 5, right? I took this 3 and this plus 2, and we said, oh, together those make 5. So we added them together, which means that we really are tempted to say addition property of equality, but it didn't affect the right-hand side. It only affected the left-hand side. Okay? So that's not addition property of equality. That has to be on both sides of the equation. This one we call combining like terms. So combine. Anytime it happens on one side, it's combine like terms. Okay? So when we look at the first 4 and we compare that to the second, or not compared to 1 through 5, look at 1 through 4 and compare that to 5 through 7, do we notice anything different? Okay, and I've said it a couple times, but let's see if I can, I don't know if I can zoom out far enough to see all of them at one time. My computer kind of gets in the way when I try to do that. Too much stuff here. Okay, so when I look, I can zoom in a little, we'll have to look at them separate. When I look at these first 4, remember we said they had to happen where? On both sides of the equals. Right? And when we look at the last 3, when I look at my equations, it didn't affect both sides. It can, but it doesn't have to. With the first 4, it has to happen on both sides of the equals. So for 1 through 4, it's going to be on both sides of the equals. For 5 through 7, it can be on only one. Oops, y'all can't see what I'm writing. Okay, so that's going to be the difference. All right, the next video is going to go through a couple of practice proofs so that we can see how to build a proof and what to look at on each side.